In this video, we're going to review completing the square. Completing the square is a process where you take a quadratic expression that you're given in standard form and you convert it to vertex form. So you're given something that in the general case looks like this and convert it to something like this. Here's an example below. You're given a quadratic expression in standard form like so, and you want to convert it to vertex form like this. And you might want to do that because you are looking for the vertex, because you're doing a word problem that involves a maximum or a minimum that you're looking for. So how do you do it? Well, you're going to temporarily and artificially create a perfect square trinomial. That's where the name completing the square comes from. And then you're going to factor it. So what does that look like? Here's our example of a standard form quadratic expression. So the steps here are listed on the right, and I'm going to do them on the left. So first you want to common factor the coefficient of the x squared term out of only the first two terms, and you need to be careful of the signs. So the coefficient in this case of the x squared term is this -2. So we want to factor that out of only the first two terms. So if I factor out a -2, I'm left with x squared, and you have to be careful of the signs. If I factor out a -2, the second term becomes -8x. Now, I only want to factor out of the first two terms. I'm going to close my brackets, and I leave my last term there, just sort of as a spectator for the moment. So that -2 has only been common factored out of the first two terms. Now, in the next step, we're going to take half of the middle x term that we've got now, so half of that middle x term. We only want to have that coefficient. So we're going to take -8 and have it, and we're going to write it down over here just so that we remember it. Now, that's going to come in handy later. Then we move to step 3. We're going to square this number, so -4 squared becomes 16, positive 16, and we're going to add and subtract it from the two terms inside the brackets. So that would look like this. Y is equal to -2 x squared minus 8x. We've taken half of this, which was -4, squared it. We're going to add it, but you can't just add something out of nowhere, so we're going to subtract it back off so that these two would actually cancel out to make 0. And then we still have our 5 sitting idly outside. Now that looks strange that we've now just added something and subtracted it back off. It seems like it doesn't have a point, but we'll see in a moment why we've done that. So I've just copied what we arrived at above here. Now we're going to move the subtracted term, so we're going to move this -16 out of the brackets to join that 5 that's been waiting outside. But to move it outside of the brackets, we have to multiply it by this -2, because this -2 is multiplying everything that's inside the brackets. To get this out of the brackets, we have to do that multiplication. So that would look like this. Y is equal to -2 x squared minus 8x plus 16. This part all stays inside the brackets. But now moving the -16 outside, -16 times -2 is positive 32, and then we still have our 5 waiting out there. Now we could combine that 32 and that 5 in this step if we wanted to, or we could do that later. So that would be 37. Now we want to factor the expression in the brackets, and it says here that the number we wrote down at the side before in step 2 is going to be the second term in the brackets. So x minus 8x plus 16, this is a perfect square trinomial, and if we were to factor it, and you can demonstrate this to yourself if you like, on a separate piece of paper or at the side of your paper, we would get x minus 4 squared, and it's important that that squared is there. So x minus 4 times x minus 4 would give you back this. And then we've got our 37 left outside. So our original standard form quadratic has now been written in this vertex form quadratic. Those two are equivalent, but we've converted from this form to this form by this process of completing the square.